when an organization adopts Sphinx, we see that their speed of model development goes up massively. As a consequence, of course, people in charge of model risk and model governance also need to be able to monitor these models as they're rolled out, inspect their outputs, introspect how these models are operating, and otherwise add a level of governance and stability to this new wave of models. Sphinx can help with this as well. It not only allows model reviewers to quickly introspect models, understand their behavior, run experiments, create challenger models, etc. It also makes the process of documenting and understanding model risk so easy that teams are generally quite happy to do it themselves. So I'll start with a quick example here where I'll say, let's say we have some outputs from an existing AI model for credit line decisions. Let's say it's a reasonably black box model for now. They're in some CSV file, the decision so far. Let's start with a simple question. Is the rate of overrides varying by time? Maybe there's some kind of model drift here, and we'll try to verify this is an appropriate statistical test. So let Sphinx get right to work. It'll load the data. It'll understand what's going on through our data interpretation layer, and it will go plot this data for us so we can see it. It doesn't look like the override rate is varying too much, but Sphinx will actually pick the appropriate test. In this case, it looks like it's going to do a chi-squared test and establish that, yes, there's not really too much evidence that the override rate is varying over time. Great, let's try something more complicated. Can we make a challenger model, or I guess something like a challenger model where we say, can we use the interpretable features we have, like delinquency rate, the current credit line, the requested credit line, to try and predict if there is going to be an override from this AI system. This will allow us to then say what features might be driving the AI decisions. We'll build in this case, seems like Sphinx is going for a basic linear logistic regression type model. And it finds, interestingly, that this model actually doesn't work. I find it interesting that Sphinx actually is able to call out that even though the model trained and has a 75% accuracy or something like that, it's always predicting a single class. It's predicting no override. Obviously, override shouldn't be a common event. Sphinx detects this and is actually going to take steps to build a model that accounts for the class imbalance, accounts for the kind of imbalanced nature of the decision, and deals with the rare event more appropriately. So here it's investigating the class balance, finding that certain predictions are not actually being made at all. It will now adopt a different method where it's going to use a different class weighting. Now, of course, it actually has trained a model that seems to work a little bit more accurately. And you can see here that it's actually showing us the separation between these two distributions for overrides and not overrides. It looks like Sphinx will also try a decision tree model, increase the complexity a little bit, see if that makes it better. And of course, the AUC with the decision tree seems to be about the same. So we've probably hit the limit of what we can get with simple models here, and Sphinx will show us this. The green and orange lines being quite close indicates that we're not getting too much advantage from additional nonlinearity. And of course, the original model, the plain logistic regression with no tweaks, is quite bad, which Sphinx is able to detect and correct on its own. And then finally, we can proceed to the last and perhaps most important step here, which will be to figure out all that we've done and write it down in a way that we can enter into a system of record. So let's summarize the findings, let's summarize what the challenger model has done, and also now that we have some basic understanding of what this model is doing, let's outline some risks that the overall AI model that we're investigating may expose and what we can potentially do about them, both follow-ups and summary. And Sphinx will write this in natural language, in plain English. You can obviously impose whatever structure you want if you have a certain rubric or a form that you need to fill out for model validation. But here, of course, it's just free text, and we can see that Sphinx is able to say, not only are we verified the stability, we used a challenger model, but of course we can say the challenger model was not that predictive of the decisions. And so that indicates things like, for example, opacity and explainability might be a big problem here because we're not actually able to explain the model's logic fully using the features that are supposedly used, as well as, of course, the stability, robustness, fairness, and bias, and other questions that might make sense here. And we do see a list of reasonable steps of further investigation, things like using SHAP or LIME or other methodologies for deeper model introspection, all of which, of course, now Sphinx could handle if we were to make that request to the model.